Lesson 4.7 on transformations of polynomial functions. In the world of graphing calculators, this one should be pretty simple. Describing transformations of polynomial functions, you can transform graphs of polynomial functions the same way you transform graphs of linear functions, absolute value functions, and quadratic functions. So we're going to see some examples. Right, so we see things inside the parentheses doing our horizontal shifts, except it's opposite, right? Vertical shifts happen after the exponent stuff is done. Reflections give negatives on the f of x or on the x value itself, and then coefficients are going to give us stretches and shrinks. Best way to get through this is to just make the graph, right? So here we have x to the third. So on our screen is a graph of x to the third. And we need to graph x plus 5 to the third and then plus 2. So what I see is this plus 5 is going to shift my graph 5 units to the left, and this plus 2 is going to shift my graph 2 units up. So this point that was right here on the origin is now going to be at left 5 up 2. Right? So that's going to be the main transformation that happens here. It's going to just be a translation of that graph left 5 up 2. And then all I'm looking for you at this point is just a simple sketch, right? It was like that. And I kind of missed my point there, but on your paper a little easier than on my screen. For these examples, I would just graph these on the graphing calculator, and then we can sketch them onto the graphs on your notes, right? So I have x to the fourth. So y equals x to the fourth. And for my transformation, I get negative 1/4 x to the fourth, right? So my difference then is that negative 1/4 out front. The beauty of the Desmos is we can see in color, right? So the green is my original. The negative, the transformation version is in the purplish color, right? So we see then that it has a shrink by a factor of 1/4, and it flips over the x-axis. I'm running this video off my computer and not the board, so I'm not going to write all of this down for you, but your answer for right in this area would be shrink by a factor of 1/4 and flip across the x-axis, right? So we see then that our graph would look something like this, right? It's more stretched out and it's flipped across. For part B, we have x to the fifth and then 2x to the fifth minus 3. Now I know that this minus 3 is going to shift things down 3 units. Okay, what I need to see is what is this 2x going to do, right? So let's clear out our olds. I have y equals x to the third, or x to the fifth, and my second one is y equals 2x to the fifth minus 3. Right, so I do see that shift down 3. But notice that this graph tightens in, right? It grows much faster. So here we have a horizontal shrink by a factor of 1/2 and translate down 3 units. So it's tighter, it grows faster because of that 2 inside the parentheses. Let the graph G be a vertical stretch by a factor of 2, followed by a translation of by a translation 3 units up of the graph x to the 4th minus 2x squared. So we need to write the rule for G. Well, I know that this translation of up 3, I am going to add a 3 somewhere at the end, most likely. So let's get to work here. We have f of x equals x to the 4th minus 2x squared. To get that translation of up 3, right, that's just going to be a plus 3 at the end. Vertical stretch by a factor of 2 is just going to be multiplying this by 2 before we do that translation of up 3. So that's going to be 2x to the 4th, and then distribute the 2 minus 4x squared, and then that plus 3 gives it that translation of up 3. Lean into your graphing calculators for this lesson. The worksheet should be fairly simple of graphing some stretches and shifts, some translations of graph, transformations, I guess would be the better word, and you should be good to go.